There we go. Hello, everyone, and welcome to day 34 of Handmade Hero, the show where we code a complete game from scratch using nothing but our bare typing fingers. You may ask, why are we doing this? And a lot of people do ask a lot of times, why aren't you using this? Why aren't you using that? Why do you use this editor? Why do you use this language? Why don't you use an engine? And a lot of the answer to that is actually kind of complicated, and I suppose that I don't explain it often enough, so maybe I'm just going to take a couple minutes here just to say why we do what we do on the stream and why I think it's important. So basically, the first thing I just want to point out to everyone out there, and this has really nothing to do with my own personal preference or anything like that, the game industry runs on C and C++. That is just the truth of the situation, and basically almost everything that you play was programmed in C and C++. The engine for the game was written in C and C++, and it is extraordinarily rare to find games where that is not true. It doesn't mean you can't. There are examples of games written in all sorts of languages out there that you could find, and that's always good, but everything that you know about and everything that sets the bar for gaming is C and C++. If you go out and you buy the best-selling game of last Christmas, if you buy Call of Duty or you buy Grand Theft Auto, they weren't written in F#, they weren't written in C#, they weren't written in Java, they weren't written in Python, they weren't written in PHP, they weren't written in JavaScript, they weren't written in HTML5. They were written in C and C++. So at the bottom of the basically at the base layer of every game, that is what is there. And maybe someday that'll change, it's hard to say. But the truth of the matter is C and C++ is what runs the game industry. And so at least for the time being, that is what people need to know if they are programming games and they are programming games seriously at a low level trying to do performance-oriented programming. That is just what the game industry runs on. Now, it doesn't mean you shouldn't go programming something else, depending on what your goals are, but it does mean that when I do teaching on this stream to try and teach low-level game programming, that is what we are going to use because that is the industry standard. So that is just the case. Now, I happen to like C and C++ as well. I like having control over what I program. And one of the reasons that I like C and C++ a lot is because I like to basically be able to nitpick every little thing. I'm very detail-oriented in that way, and I like to be able to know that after I go over my first pass of programming, I always have that room to kind of go down there and drill down into every little bit and have complete control. I don't want the language doing anything for me. I want to be able to do it all myself. And that's just sort of a philosophical thing, and I don't want to foist it on anyone else, but I can just basically tell you that that is the way I make games, and that is the way I enjoy making games. I think there's something kind of just at a fundamental level really very much fun about programming a computer directly. It's why I got into this business in the first place. It's what still gets me excited about things when I'm actually programming. I like being the person who is in control right from the CPU all the way up. And in fact, to be honest with you, nothing aggravates me more these days than the fact that the operating system is kind of in my way. I really don't love it. And it's one of the reasons that one of my personal goals for the stream is to eventually get us to the point where we're programming on a Raspberry Pi, because I would like to get the operating system completely out of the picture so that we can start doing stuff at a really low level. And maybe we can even try to do that on the PC sometime, but the problem is the sort of the mess of devices and specifications for how the devices work on the PC makes it a lot harder to do something like that in a short time scale. So anyway, that is why we are using what we are using. And one of the big things that I just want to say is, if that is something that people aren't super interested in, that's totally cool. I don't want to be dogmatic about stuff. I think everyone should use what they want to use to program. But I would also say that there's something to be said for the fact that low-level programming does have really some pretty interesting results, and that we have made some pretty amazing things with it. If you look back over the history of game programming, C and assembly language have given us some of the most formative gaming experiences that have ever occurred. Things like Doom and Quake back in the old days, all the way up to the things that you play today. And I think there's just something kind of interesting about that, and I do think that it's worth learning. I also think that the more you know about how to program a computer at a low level, the more powerful you are even at the high level. So when you do jump up and you start using someone's prefab engine like Unity or Unreal or something like this, and when you do jump up there and you use something that's like a higher level language, you want to use C#, you want to use something like that, knowing what it is that those languages have to do to provide the services to you that they provide, such as garbage collection or such as the animation system in Unity or any of these sorts of things, does kind of put you at a significant advantage to someone who has no idea how those services work. Because if you've been there and you've implemented one of those systems yourself someday, even if you choose not to use it because someone else provides a better system that you can license, knowing how it worked allows you to use it in a much more intelligent way and avoid the kind of pitfalls that often happen when people who don't know anything about these sorts of systems or how they work try to implement relatively complicated games in higher level languages or engines. Going into those sorts of problems not knowing what the support engine and what the libraries have to do in order to do the things you're asking them to makes it really hard for you to sort of make good decisions about how you use them and how you structure the code even at a high level. The truth is we just haven't gotten to the point yet where people can program games and not care about the hardware or not know anything about it. Maybe if your game is very, very simple, that's true. But as your game gets more and more complicated and more taxing on the system, it really becomes important for you to know, sort of at least at a basic level, how all these things work. So personally, I just think it's a great idea for everyone to have the experience just once to kind of go through the complete pipeline of a game and see how everything works from the bottom all the way up to the top. It's very, very empowering. I think it's a great idea, and it doesn't take that long to do. An hour a night is all we're doing here, and I think we make great progress. There's so much that you can learn in just that hour, or if you even go off and do it on your own, there's so much that you can learn in just a little bit of time. And so I highly recommend that everyone seriously consider that, even if they are someone who thinks that it's a waste of time to program C and C++ or a waste of time to write your own engine. I'm not here to convince you otherwise, but I am here to say there is a lot to learn about how things work, and the more you know about that, the more empowering it is. And there's also a surprising amount of fun to be had at the lower levels when you start to get pretty facile with it, and don't knock it. There's something to be said for that. You know, back in the 70s and the 80s, huddling over a personal computer and just figuring out how to make it do the basic stuff that it could do was just a really rewarding experience, I think, for a lot of people, and I think we can have those kind of experiences again. So I think there's just a lot of positive stuff to say about the sort of stuff that we're doing on Handmade Hero. So I would encourage everyone to maybe not focus so much on questions about whose language is better or what editor you should be using or why you're not using an engine or those sorts of things, because really those questions don't matter very much. When you are making a game, the big picture and the big questions often are a lot more important than those things. And it's really about the craftsmanship, your knowledge of the programming, your knowledge of how to use the hardware, and your kind of ability to focus on what's important in a project that really matters. And so I think we're doing a pretty good job of this on this stream, and I think we've made some really great progress. We haven't even made it through one full work week yet. It's day 34. Day 40 will be the end of our first work week, and we have so much to show for it. We have features that even professional engines don't have. Looped live code editing is something you can't even buy today, and we've already written it. So I think there's a lot of good stuff going on here, and I would encourage people really to just have fun with it and maybe don't worry so much about a lot of those other things. All right, that's my PSA for the day. I am done talking at you. It is time to do some programming because we're at a pretty fun part of the project right now, if you ask me. All right, so if you are following along at home with the source code, today is day 34, so you want to unzip day 33 source code. If you have pre-ordered the game on handmadehero.org, you will have gotten a link in your email. You can click on that link, and it will have a zip file. Inside that zip file is one zip per day. You just go ahead and you find day 33.zip, you unzip that into a directory, and you are exactly the same spot in the code base as I am right now, and so you can follow along at home exactly the same way that you see me do on the stream. Okay, so if you remember, we had just sort of finished virtualizing our tile map yesterday. What we had basically done is we're sort of making a scratch game right now. We're basically just sort of laying out what the sorts of things we want our game engine to do so that we can go write our game engine. And one of the things I did just before the end was I made it so that every time the player moved to a new tile, we moved the camera. Now that's not maybe so nice because people would probably prefer some smooth scrolling there. So one thing that might be kind of fun to do would just be to go ahead and add the smooth scrolling. So why don't we just do that for now because I feel like that's probably a pretty reasonable thing to do. You know what, one thing I haven't checked recently, by the way, I haven't checked to see whether we have any, I wanted to double check. Because we had added some things at the end of the Win32 platform layer stuff. I want to do that Control-Shift-Escape to bring up the task manager, and just make sure we're not doing anything weird with our memory. I want to make sure it always stays nice and constant, and it does. So that's always good. Anyway, we'll be adding a lot of features that allow us to track our debug stuff, probably not too long after we get sort of our renderer chops up a little bit. But anyway, so what I'd like to do is just go ahead and make this smooth scroll. Now, if you remember how this worked, we basically were drawing the tile map. We're drawing the tile map by starting at whatever tile the player is on, and then we're just asking what the tiles are that are around him, and we're drawing them. That's all we're doing. So instead of moving the player sprite like we're doing now, it's all relative, like Einstein said. Really all we have to do is we just have to move the map instead of the player, and then we'd have smooth scrolling, right? That's really all we'd have to do. Right now we're moving the player based on his offset, but all we have to do when we draw, instead of drawing the player sprite offset from the tile, we can just draw all the tiles, offset, and the player stays in the middle, right? Pretty darn simple, but I feel like that would just be a funny thing to do right now. People were asking about smooth scrolling, and I just thought it would be funny if we go ahead and do that for them. So let's just take a look at how simple that would be. Again, we will not really be doing smooth scrolling in the game because I don't super like that feel of a game. I like walking from screen to screen. But I just wanted to make sure everyone would be aware that the engine could support either one, and we're not actually cutting any corners there. It's just something that I don't think is particularly interesting. So in here, we do our drawing with our center X, center Y, right? And basically all of the tiles, when we draw them, are based off of that center X, center Y. So if we wanted to, we could just go ahead and add the player's offset in here. So right now you can see the player's offset is being used to offset their position, right? Right here. We can just go ahead, if we want to, and make that offset the world's position the opposite direction, right? So instead of adding that in here, I will just subtract it from where we're drawing the tiles, and instead of subtracting this in here, I will add it to where we're drawing the tiles, right? And that would be a pretty straightforward way, I believe, to make that happen. I believe. You know, don't quote me on this. But yeah, so there you go. That's smooth scrolling, right? That's the way you would normally see it in a game where the player was locked in the center and you scrolled around. Obviously, we could put logic in there for the camera about when you would actually do that scrolling if we wanted to make it so that you only scrolled when you hit the end. But these are things, like I said, we're not really doing for this game. So I just wanted to show how simple that was to conceptualize. So at this point, we sort of have to start thinking about some other things here. First of all, we've never really tested out our virtual tile system or any of that stuff. We've never tested a bunch of the things that we implemented yesterday. So one thing that we might want to do is start to think about making like a much bigger world and making some way that we can actually sort of zoom out and see like a large part of the world or something like this. I'm not sure how we want to do that exactly. I'll have to think about it. I also want to take a look at the to-dos in the code base right now just to see what they were, just to see where we're at on the stuff that we have to figure out on the tile system. All right, let's take a look. So we've got player movement code, which we'll be doing a little bit later. We started using the tile side and meters. That to-do is done. Let's see. We've got to do some work on our floating point map in here. That's going to be a problem. But that's about it for to-dos. Not a lot of to-dos left in our tile map system. So that's pretty cool. We did this switch that we said we were going to do. And so now we can just document this basically. These are fixed point tile locations. The top, let's see, the high bits are the tile chunk index, and the low bits are the tile index in the chunk, right? Just so we know what those are. And then we kind of said, were we going to make these offsets from the center of a tile? I don't know. It kind of feels like we should make them offsets from the center of a tile because then there's really no bias. We don't kind of have this sort of concept of an upper corner or, you know, a left or a right or anything like that. There's just the center is always the center. And it's the same whether you flip upside down or not. It's all the same. In that sense, it seems kind of compelling to make it be the offset of the offsets be from the center of the tile. But at the same time, if the offsets are from the center of the tile, I'm just trying to think about, so then we would just do a rounding operation, I suppose, to figure out which tile we were in. I don't know. It's tough to say. I guess maybe let's try making it from the center of the tile. Let's see what happens and then we'll basically say whether or not we like that one way or the other. So we basically have a tile side in meters. We could change that tile side in meters to basically be a tile radius in meters, if you will, and we could sort of start to think about it as being measured this way. So we basically have a center position, and we've got, you know, a radius out to here, and that radius is the same in all directions. So that would basically be it would be half what we were doing now. I think we said that tiles were 1.4 meters, and we were basically saying something like, okay, now if we divide that by 2, they'd be 0.7 meters in radius, right? So that was one thing we could do. Someone also suggested that they liked the idea of having of a nice 1 meter, a nice unit measure. One thing we could think about doing is making the tiles be 2 meters long. If the tiles are 2 meters long, the radius would be 1 meter. I don't know if that's a compelling thing. Hard to say. But it is something to think about. That's another thing we could try. So I don't know. I don't have a strong feeling today. I'm not sure what the best stuff to do is here. So I think maybe I will just go ahead. I will just go ahead and say, yeah, let's do it from the center. I don't know. I think this is a case where I just got to do an experiment here and see whether I like it better or not. I don't really know. And so if we have our recanonicalized coordinates, basically this is the place where it's going to affect things. This tile relative x, tile relative y is going to take on a little bit of a different meaning. If now what we basically say is, okay, this is the center, so the time that we need to offset where our tile actually was is just going to be about how far we are from that center. And when that distance gets larger than the tile radius, then we will go ahead and update it. So let's take a look here. We're saying the world is assumed to be toroidal topology. If you step off one and you come back on the other. Oh, you know what? Maybe I can think of a reason why you wouldn't want this. Maybe I can. You know what? Can I? No, I can't really. I don't think I can. I almost did. I was thinking maybe that there is a reason not to do it. So let's take a look. I'm going to take a look at what happens when we do this. All right, so if we basically said, here is where our center point is on the number line. We're at the center of the tile, and that's right on a numeric boundary, all right? That's 0. And so then we have some number crossing where basically if we go over that crossing, right now it would be 1.4. This would be negative 1.4. This would be positive 1.4. When we do the divide out by 1.4, what we would get is essentially we would normalize this down to a negative 1, positive 1, right? And here's our 0. And we've got, you know, our vector here. What we would then do, I guess, is instead of doing the flooring, we would just do a rounding function, right? Because we just want to know the closest whole number. Because remember, we're talking about the tile. We've got an offset from the center of the tile. And now we want to renormalize one of our coordinates. If it was pointing outside the tile, we basically just want to find out where the nearest whole number was, and then we're going to make it an offset from that, right? So we're just talking about a rounding operation now. We just need to basically do a rounding operation. So how do we want to do, how do we do that rounding operation? And the other question too is, the rounding operation, that we would have to do, we also have the question of how do we support that rounding operation in float? Because we're going to have to handle negative numbers now. I don't remember if we handled negative numbers in our rounding, probably not. So basically the way we were doing rounding before is we were basically just adding 0.5 and then truncating. So basically we had the truncation. The truncation goes towards 0, right, depending on the circumstance. And so basically we would have to change the direction that we added in order to do the rounding when we get to 0. We'd have to make it flip, right? Because what we were doing before for rounding, I don't know if you remember when I said this, basically for rounding, we had something where we would take, the 0.5, right? And we wanted anyone who was in this part to round up and anyone who was in this part to round down. So what we did is we just added 0.5 and then truncated. So that would push people in the upper quadrant over here, and then the truncation would knock them back down, and people here would knock up as well, but they would not pass the next whole number, so they would come back down. If we have negative numbers, unfortunately, I believe since the rounding direction flips, the truncation direction flips, we would technically want to be subtracting 0.5 if we wanted to round properly. And so we didn't actually implement that. Again, we have not actually written that in our intrinsics, right? All we did was this, which will only work for positive numbers. So we'd basically be in another circumstance where we'd have to lean on math.h. I believe we can use the round function there. Let's see, CRT round, or I should say round f, I believe. I don't actually remember if they actually have one of these. Let's take a look. Although we could also just keep using floor and do the bias on floor as well. So let's see what we actually have. Yeah, so there is a round f. I don't know why it wasn't getting found. So round f is what we would be doing. And so really, yeah, I think this basically ends up being exactly the same thing. And we're still, this is our intrinsic stuff is basically going to have to re-implement these functions. Now they will actually get we did see that when we turn on intrinsics and FP fast in our build line, I don't know if you remember this from one of the Q&As, if we turn on O2, OI, FP fast, we don't actually call the C runtime library for these, I think, in a lot of circumstances. And so technically we wouldn't probably have to re-implement these ourselves. The compiler would do them for us, but we might as well learn how to implement them anyway. So eventually we'll get around to that as well. All right. So I believe all we really want to do here is make sure that these things round properly. The truncation's there, sine and cosine. So we are basically calling the C runtime library for these sorts of things, and this will be our to-do to convert these to our own at some point in the future. Okay. What are we complaining about? Oh, we have an extra parentheses. There we go. So if I want to do that, and I don't know if anyone actually uses that right now. Okay, there are some people who use it for the rectangle drawing routine. So I'll double check to make sure that they still work properly, but I believe that they do. Let's go ahead and make sure that there's no weirdness there. Yeah, everything's fine there. So if I want to go ahead and make this change to do it on the center point, basically all I'm going to need to do now is I'm going to have to say, all right, we're going to take whatever that tile relative thing is divided by the tile radius in meters. Let's see here. And so you can kind of see, in some sense, you can kind of see what I'm a little concerned about. In fact, this was the thing that I sort of said in my head, and maybe as I'm starting to implement it, I'm thinking that maybe I was right to be wary of it. But basically, here's the part that I'm a little concerned about. So the only thing that I'm wondering is if we do it from the center point, so this is the center point of a tile, right? And then I'm dividing by the radius, which is half the length, because this is the point at which it crosses over. Well, no, I guess I can still just divide. No. Okay, I'm thinking about it wrong. I can still divide. I don't need to divide by the radius. I can still divide by the tile size, the tile side in meters, and do the exact same math, because the rounding is the thing that makes the change, right? Round real 32 to int 32 is what will make the change for me, because basically what will happen is if I go half the distance, which is the radius, the rounding will push me to the next center point. So I really don't need to think about the radius at all. I can really just use the tile side in meters again. It's really just a question of how I do the snapping. That's kind of nice how that worked out. I don't know if you guys saw that. Hopefully that makes sense. But basically, I was thinking I was going to have to do something different with like the fact that you only go halfway and then you have to go a full one to get to the next one. But the rounding basically, I think, takes care of that. So I think if we do that rounding, I think we're all good. Can't think of any particular reason why anything else changes here. Does anything else change? Pretty much just our assertions change. We basically have to make sure that we're bounded on either side by the radius now, which is this way, like that. But I think that might be all that changes. I don't know. So I'm gonna say that. So I think that just works. Does it just work? So I just divide by the tile side in meters, around, that gives me my offset. I do the offset on there. I subtract however many I went, which seems totally fine. Yeah, I don't know. Gosh, that seems a lot too simple, doesn't it, people? I'm a little nervous about the fact that I'm forgetting something or missing something, but that seems pretty simple. So if that was the entirety of the change, then really I think the only difference here would be how we draw the offset of the guy in terms of the fact that now that it's from the center instead of from, instead of from, excuse me, yeah, it's the center instead of from the corner. So let's take a look at how we were drawing this here. Center x minus world meters to pixels, game state player p tile relative x, plus rel column. So basically the problem now is when we're drawing these, this is the min x and the min y, but now this is technically the center x and the center y, if that makes sense. Because we're basing it around the player, and that relative offset is the center. So really all we need to do is we basically just need to take a little bit of a step there and make this be, I should probably pick a different name for center x. This is actually screen center x. Would make a little more sense so that we know what we're talking about here. So screen center x, screen center y. And so really all I need to do is say, well, okay, now we're computing the center because this tile relative x, tile relative y, those are the relative positions of the guy from the center of a tile. So if we want to draw the tile around them, we have to basically take the center and subtract half the tile radius from that, if that makes sense. So I will go ahead and do that. Of course, we're passing the min x and the max x inverted now, which I guess we don't even really have to do that. We could just go ahead and normalize these things as well. Sen y minus 0.5 times world tile side in pixels, like that. And I think that is mostly all we would need to do. I'm not sure. Again, I'm just kind of slapping that down there. Oh my goodness. Well, that's no good. What did I do? Oh, whoops. This doesn't need to be half at all. Well, it could be. We could just base it off the center. That's what you would do for that. But yeah, I don't know if you saw what happened there. Is I changed the computation as if it was always going to base off the center, but then I was still using the min and the max. Not very good there. All right. So let's see. Seems pretty good. Does that look good to you guys? It looks good to me. Looks like it's working to me. He seems to move the tile that he's on. His active tile moves every time we do that. So yeah, that seems pretty good. So maybe now would be a good time to start thinking about, and I guess now that I think about it, I'm going to have to, maybe I'll have to have a key here, maybe the space bar or something like that, or one of the buttons. I think to speed this guy up so I can walk around the world a little faster. He's pretty slow for debug purposes. I don't know if, depending on how the game works out, maybe that won't be too slow for the game, but I probably want to have a key that allows me to scoot around the world just a little faster. So what I'm thinking about here is perhaps we just have a little thing temporarily. Again, the player movement code is really just not something I want to talk about yet because we're going to talk about that a lot. But what I could do is basically say that there's a player speed, and we'll go ahead and make that player speed be based off one of those keys. So I know in here I basically said that those key down messages, right? We were processing the key down messages, and I think I added some extra ones, right? We've got DK space, and that was the back button. We've got the different buttons here up left. So maybe when I push up, I'll have them go really fast. So I'll just say whenever the up button is down, right, and I don't remember that's action up, I will just go ahead, oops, didn't mean to move that in there. I will just go ahead and make the player speed be quite a bit more than it was, right? And so now when he moves around, if I want to, he can go into acceleration mode, and that's fine. You can see, I don't know if you can see this too, when we get to the player movement code, I'm going to talk about this a lot, but you can already see now why it's so important to do good player movement code, because like, you see how we get stuck on things and stuff? That just feels awful when games have this problem a lot of times, especially if they're not done by people with a lot of experience, they'll have these sorts of problems. And so one of the things that's kind of nice is when we do the player movement code, we'll be talking a lot about how to not have that kind of stickiness. Like you want to be able to aim for a door and just go right through it. So that'll be fun code to write when we get down there, because there's a lot of interesting things to talk about in there. Anyway, so what I want to do now is I want to kind of get this world situation a little more straightened out. Let's go ahead and say that we're going to do, a much larger world. Let's try to put a much larger world in there now so we can just start to test the systems, make sure everything's kosher and nothing weird is going on. So what I want to do is I want to go in and say that instead of this hand-coded tile map like we had before, let's start thinking about making something that's going to be more procedural. And so let's just go ahead and add some very basic things to our tile map system. I'm relatively happy at the moment with the way that we're sort of doing the tile map thing, so I think I might start to pull that out a little bit into its own file. I'm thinking that maybe it's a good time to start doing that. I'm not 100% sure, but I'm leaning towards it, so I think I might start doing that. I'm going to make sort of a handmade tile maybe .h, which will start to contain this stuff. And I'm going to go ahead and say that now that I'm relatively happy with it, that we're kind of have some of this stuff will kind of go in here. And I'm going to pull this thing out to basically be, I don't know what we're going to call this yet. Maybe we'll call this, maybe this, well, you know what? It's just, this is the tile map. This is the map. It's the whole map. So maybe we'll just call that the tile map for now, and that will have all of our tile chunks in it. It'll have this stuff in here. There we go. It will kind of probably, in fact, all of this stuff that was in world, really this is going to be world, but world will have a tile map because the world will have other things in it, right? Because the world will have, and it can just include it directly. The world will have actual, excuse me, the world will have actual things in it, like the entities and stuff as well. So it'll have the tile map, but it'll also have the rest of the stuff as well. Do I want that to be a pointer? Maybe I do. We'll go ahead and make that a pointer. I'm not sure yet. Okay, so now that we have one of these, what I want to do is I want to move the functions over out into here that we were using. So I'm going to go ahead and say that we have a bunch of stuff like the get tile value and these sorts of things. There's our rectangle call. We're not going to touch that. Get this out here. So this will come in. Oops, that was the CPP file. My bad. Paste that into the H file where it belongs. So the CPP file will have those get tile chunk calls in there. And these for now, I don't know. I think those will probably stay in line for now. Let's see, recanonicalize position, get chunk position 4. That's something that's based on the tile map, certainly. The tile value and is world point empty, those are certainly in there as well. And then there's a question about the coordinates and who manages those. I'm not sure exactly who that should be. I really don't know. Is this a world position technically, or is this a tile map position? It's kind of a tile map position when you think about it, because it's based on the tile map structure. So I don't know if that should go in there or not. Again, these are kind of questions that I don't know that we really need to answer all that definitively, but I might go ahead and say that that's a tile map position, and that's going to be our final name for that. It's a position on the tile map. Yeah, that seems kind of reasonable. So maybe we'll call it that. Those are tile map positions, and then we will go ahead and call this a tile map position, like that. And I will go ahead and say in here, then we will put the canonicalized coordinates. We will go ahead and put those in here. Now we could also go ahead, another thing we could do is split these out into their own file as well, which is basically coordinate-oriented stuff, but I don't know if that's necessary quite yet. So I'm going to go ahead and just do that much for now, and we will see what we want to do with that going forward. All right, so let's go ahead and make sure that those are all included in here. Make sure that that all works, and then we will go ahead and, why do I not have tile map? That's in handmade.h, that's the problem. So handmade.h, this stuff should be probably how I want to do this. See, handmade.h has these things, so I probably want one more h file. Handmade.h is kind of our basic stuff, if you will. Well, it doesn't really matter how I decide to do this for now. So So I think maybe what I'll do is I'll just do it this way. There we go. We could deal with that a little later on. All right, so now basically world becomes tile map. So basically world becomes tile map everywhere, I guess. Actually, I should say world becomes tile map everywhere. So let's go ahead and make that happen. There we go. Let's do a nice little replace there. Oops, didn't mean to stick a Y in there. And then world becomes tile map. Like that. There we go. Like this. Redefinition. Tile chunks. That's right. This is tile chunks, not tile map. This. There we go. And now this stuff is actually stuff that gets allocated, or sorry, that gets handled by our tile map. So those will all be initialized. Well, I guess I could still do it this way for now, but I want to start moving things kind of over into a little bit more proper space. We'll see how that goes. Sorry, it's a little bit of dead time here, but I just gotta kind of clean things up when you make a change like this. I guess world dot becomes tile map dot is a pretty safe change to make everywhere, so I will just make it. There we go. And now I thought we did world dot. There we go. I must have missed that guy. World position becomes tile map position as well. There we go. Toot, toot, toot. And now we've got a couple more of these guys. So world becomes tile map. Yeah. Yep. There we go. And that brought up a good point, which is this is no longer is tile map point. And oh, we already did that one as well. All right, good. So that should hopefully leave us exactly where we were, and it did. So what I want to do now is I essentially want to have a way to start writing to this tile map. What I want to be able to do is basically set the tile type of any place in the world. I don't care if it's particularly slow. I just want to be able to start writing to the tile map, right? So what I want to do is I want to do something that just starts making maps, basically. I don't know exactly how we want to do this. It's kind of a good question, and I'm not sure. But basically what I guess I would say is at startup now, when we kind of come in here, instead of having this thing, I don't really want to do this thing at all. We kind of had our 17 by 9 idea of how big a screen was. So I'm just going to vaporize this. Goodbye. And then what I'm going to do is I'm going to say, okay, in our is initialized, when we are not initialized, we are going to go ahead and do a little world construction. I don't know how many screens we'll make. It doesn't really matter. But I'll basically say something like, you know, screen X or screen Y equals 0. Screen Y is less than, I don't know, let's say we make 32 screens in that direction. And 32 screens in X as well. I don't know why not. But basically what we're going to do here is we're just going to generate whatever random stuff we want to generate. So we'll go ahead in there, and then I'll say tile X equals 0, tile X is less than whatever we said that tile thing was. I think we said it was 17. In fact, I'll go ahead and basically make some kind of define for this here, which is that screen width is going to be 17, or tiles per width is 17, and tiles per height is 9, because I think that's what we said. So we'll say tiles per width, and we will go ahead and do those, and we'll also go ahead and do unit 32, tile Y equals tile Y less than tiles per height. So I'm just going to spam down some tiles here so that we can make a world. And actually, I guess at the outset, I might as well just spam zeros everywhere, because why not? So let's just go ahead and say set tile value, and we'll pass the tile map, which we haven't decided how we're going to get yet, and we'll pass the abs tile X, abs tile Y, and we'll say that we're going to set it to 0, which means that there's nothing in there. Now the abs tile X and the abs tile Y, abs tile X is just going to be equal to the screen X times however many there were per width, right? Plus whatever we're actually on for a tile, right? That's it. That's all we're doing here, right? So that's the absolute tile index. And then we're just going to go ahead and write some logic in here to actually make something. But at the moment, we can skip that. So we're going to do this. We'll spam that in there. That'll be nice. But we do have a problem, which is we don't really know where to get our tile map from. And so we are actually going to go ahead and get our tile map from our game state now. So we'll get rid of, well, you know what? We'll have the world, I guess. Or do we really need the world? Or do we need the game state? I don't know if we should have a secondary structure for it. What the heck? Let's go ahead and do that. We'll just have a pointer to a world. We'll have the tile map for that world. And we will have, well, I guess that's all we really need for now. So we will basically say that we have a world, which we will create here. So game state world equals some magic function that we're about to write, which gives us a world. We will then say that our world is that, and we will use that world. So our world tile map, we will set the value. And we need to do all of this stuff only once now. We were doing it every update before. We don't need to do that anymore. We can basically do that once when we create that tile map. So basically what we'll do here is we'll say the world tile map equals, I guess what we can do is say that it's going to be the address of something that we push. We need this thing again up here. I'm sort of skirting around something that we're about to write because that'll be probably the bulk of the next 20 minutes is actually getting started on something that we haven't written yet that we need for this. But anyway, we'll then go ahead and write into this tile map. Well, I guess I can quickly just do a thing which says tile map dot equals tile map arrow. That will go ahead and take care of all of these guys. Oops, didn't mean to do that. And then all I should have to do now is actually go ahead and grab that tile map out after we actually create it. So we'll basically do tile map star tile map equals world tile map. Okay, so we just have to do our allocation stuff here, which we haven't really made any system for doing any of that stuff yet, so we're going to have to go do that. And then we will go ahead and do our set tile value stuff, which will happen here. And we might have to pass that a little bit more since that thing is going to have to be able to push new pages and so on. So we'll do that, and then when we come out here, we will need to do exactly the same things that we did in here. We will need to take our game state structure and grab the tile map and stuff out of there, the world and the tile map. And so now tile map dot becomes tile map arrow. There we go, going in there. And let's see where we're at. So we haven't implemented those. The set tile value we haven't implemented, but we will. The recanonicalized position, that is no longer taking address of tile map. So address of tile map is just going to be tile map because now that's a pointer, so it doesn't need to take its address anymore. There we go. And what else we got? What else we got here? Player left, player width. Okay, so the player width, we moved into somewhere unenforced. So these are actually still, we haven't done anything with the player yet, so the player width can stay out there. All right, so now we're down to just those two and the set tile value. Now what we can do, if we want to, is we can kind of skirt this for a second by actually just making it allocate ahead of time. I don't know if I want to. I'm going to go big or go home. I'm going to say let's just start this. If we don't finish by the end of the stream, it's not the end of the world. We're going to be getting into problems that are big enough that they don't fit inside one stream anyway, and so that's not really the end of the world. And I can do the super simple thing first, which is, okay, here's the situation that we have found ourselves in now, which is a good situation to be in because we need to do this eventually, and now is as good a time as any to get it started. We have a world that we would like to start setting tile maps in, and that means we would like it to persist. Now, if it's going to persist, it needs to be in our storage, our persistent storage for the game. And so what we want to do is we basically have this gigantic chunk of memory that we've got for storing the game state in. And what we want to do now is we want to start partitioning that memory up into stuff that we can use. Now, we already use a little bit of that game memory, just the first few bytes of it, for our game state structure, because we did that just as a test, right? We did that, and we're still using it to store the player. That's why the player's position can persist across frames. Now, what you may not have realized, and what we were doing that whole time, is we were recreating that tile map every frame. The way we were doing it before, remember, it was all in game update and render. So when we came into game update and render, it would just create the tile map on the stack, create the whole world right on the stack right there. We don't want to do that anymore. We actually want our world to be persistent. So what we want to do is we want to start using some of this game memory to store our tile map. But of course, we don't actually know how much tile map we actually need to store because we don't know how many of those pages are actually going to be filled. We virtualized our tile map, and so we only store places in the world that actually have tiles in them, but we don't know how many there are going to be. So what we want to be able to do is basically use a little bit of our bytes for the basic tile map structure, but then we want to allow the tile map every time it needs to basically take a little more memory and a little more memory and a little more memory from the pool in order to store those pages, right? In order to store those pages. So all we really need to do at the start, right? At the very start, we're not going to do anything too complicated here. All we need to really do at the start is just have something that can get us some memory in that permanent store. So basically what we need to do is we need to basically say, we've got a struct here, we've got a world. What I want to do essentially is I want to basically, have a thing that's like push memory. I want to basically get some memory. I want to put some memory onto the stack, or reserve some memory, grab some memory, however you want to think about it. And I want to basically, I want to push a struct. I want to push world on here, right? So I want to get one of those, and then I want to do that again. I want to push the tile map, right? I want to be able to get those so that we can use them. Okay? Hopefully that makes some sense. So I want to get those two things. And what I want to do furthermore is I want to be able to specify where those things go. So the world and the tile map, I want to make sure that we know exactly where they're going. So I'm going to say that I want to have sort of the concept of a particular pool, a particular place where this memory is coming from that allows me to sort of control a little bit more specifically where the memory is used. So I'm just going to pretend I have one of those as well. I'm basically going to say that there is some new thing. I'm going to call it a memory arena because, sometimes that's it's an arena. It's a place where people fight, I guess. I don't really know. I'm going to say that I have this thing called a memory arena, right, that I'm going to be able to use to control these sorts of things. It's basically something that will allow me to say where I want this stuff to be, and I'll just say that we basically have the world arena is the thing that the world uses for now. So I'm just going to say that we have that, and we'll see. Like I said, the way I like to code is to just kind of write the first thing that comes to mind and see how it works and go up from there. So I'm not going to even say what's in there yet. I kind of have a guess because I've written a lot of these before, but I'm just going to say I want to be able to say at any given time where things come from. So I'm going to say that these things come from that world arena, and then they'll just get added on there, right? So, given that's the case, I do need a way of initializing that world arena. I need to initialize that world arena with some memory, so I need to be able to say something like, initialize arena. I need to pass it the arena that's in question. In fact, these should probably be addresses, right, because they're modifying that arena. So I'm going to say I got that world arena. I need to initialize it, and I want to tell it where to put its memory, right? And the memory that I wanted is on this permanent storage. I don't have anything else that's going on the permanent storage at the moment, so I should probably be able to initialize that with wherever we are at the beginning of permanent storage. So I might basically say, all right, I don't know how big the permanent store is. Let me go ahead and see. I believe we passed that. At least I hope we did on here somewhere. Let's see. Game memory, permanent storage size. So there it is, right? So we've got the permanent storage size. So I'm basically going to say, well, the permanent storage size of the arena, right? Excuse me. Permanent storage size minus the part we used, right? Which was the game state size of. Did I make my own size of? I don't think I did. So let's use this. Size of game state. That is how big it is, and the pointer to it is just going to be the memory, that permanent storage, wherever that is. It's going to be that plus that game state structure, right? It's going to be. I'm just basically saying we're not going to touch that game state structure's memory. So we're going to point right after it. Does that make sense? So basically, I'm just going to say that I'm going to initialize that arena. I'm going to say you can use all the memory because we don't have any other arenas yet. So you can use all the memory that's in the whole thing. But what I want you to do is I want you to use it at the part that starts right after the game state, right? And then when we do this push, I want you to get the memory out of there, please. That's what I would like you to do, right? And so all I really have to do now is I just have to implement those. I have to say, I've got this initialize arena guy. So I don't know, that's something that takes this arena and initializes it. So that takes this memory arena that it's using. It takes a size. So we don't have, do we have a size type yet? I don't know if we do or not. I hope we do, but we don't. We don't have one of those yet. So what did we actually define our memory to be? We defined it to be uint64s. That's probably not so necessary. That seems like maybe that's a bad idea. To make those be mandatorily uint64s, do we want to do that? Do we not want to do that? I'm a little torn. A little bit torn there. Just a bit. Just a teens. I want to know whether we should basically say that this is 64-bit and 64-bit and 32-bit and 32-bit. Seems like we probably should. You know, basically what I'm saying is, should we have something that's essentially a size T type? A type that, like the one that C defines, it's basically going to be the size that's necessary for a memory to record however big memory could potentially be. I don't actually know which one of those I actually want to do. I don't know that I really need to deal with that right now because I don't know that we're ever going to store anything that's above 4 gigabytes inside one arena. So many choices. Let's go ahead and say that we do have that. Let's say that we do have a size T, and that size T type, I don't know what I don't really have a good name for that one. So we could just call it size T, or something like this. We could call it, you know, a memory index, something like that. Something that actually can be the size of memory. I'm really not sure. We could call it an int pointer. We call it a lot of things. I do things a little bit differently in my own code, and I'm trying to think about what's the best thing to do for the circumstances that we're in here. And I'm thinking, yeah, that I just kind of want something like memory index or something like that. I'm going to call it memory index for now. Nothing else is going to use that, so we can always come back to that later and make it something else if we don't like it. All right, so we're going to have a memory index that's the size, and we can have a memory index that is the offset, or rather, that is the location. In fact, you know what? I guess this is just a pointer. This is the pointer, the storage area. So this is the storage, and that is all that would really need. So our arena will have those two things. It'll have the size. It'll have the storage. It'll have the base pointer, I guess we can call that. And then we can just say, like we have our used amount, and our used amount is going to be 0 at the start, let's say, because we haven't used anything inside the arena. And then when we have our push struct is basically just going to be a function that returns some memory, like this, and it is going to take that memory arena, like we said, and it is going to take a size to push, basically a size that we want to push on there. We're going to take the used size of the arena, we're going to increment it by the size, so we're basically using up a certain amount of the memory in there, and we're going to make the result be wherever the arena's base pointer would have been at that point. So the base pointer plus however much was used before the call is sort of the first free part of the arena, so that's where we'll return as our result. And then we'll say we use that much, and then we'll return the result. And of course, we would like to assert here, we'd like to assert that the used amount plus the size is less than the total size of the arena, if that makes sense, or equal to. We could go right up to the end if we had to. And so then we'll do that push struct. Now what we want to do here is we want to be able to say push a struct that is this size, so we're going to need a macro for that, because basically what we want to do is we want to say when you do a push struct and you give it a type, you give it the arena and you give it a type, we then call our push struct function. We do the cast here, we do the type star to cast it to the right type, whatever the person asked for, and we do the size of automatically for them, so they get the right size back as well. And there we go when we pass the arena. So that's all nice and good. What are we complaining about? Saving. Okay. So now we actually need to put those things in our arena. I forgot to do that. So we go in here and we say, there's our arena. We've got our memory index for the size. There we go. We've got our memory index, or sorry, our uint 8 star for the base. And then we have our memory index for the used portion. There we go. And Let's see. What did I do? Oops. Well, no. What was the what are we complaining about? It takes memory arena. Did I typo that or something somewhere? I did. That's supposed to be memory index, not memory arena. So all we have to do now is implement that set tile value. That's going to be over in our tile file. So we have to go ahead and implement that. You know what? I realized I forgot to put my index card up. Of course, it's a little late now, but that probably means I've been typing behind my head a little bit. I apologize for that. One of these days, I'm going to get around to writing the little thing that automatically puts a window there. I apologize for forgetting sometimes. Really what I want to do is whenever my cursor goes there, it moves my head to a different side of the screen. That'd be future technology right there, people. You know what I'm saying? That'd be future technology. All right, so for now, the world of tile map, I'm going to go ahead and pass that arena in here as well, the world arena. But later we might sort of make it so that that's permanently sort of stored in the tile map so that it doesn't have to. But anyway, so I'm going to say that we have a memory arena here. We've got the arena. We have our tile map that we are trying to set the value in. We have our abs tile x, our abs tile y, and then we have our tile value, right? So all we're really going to do here is we're just going to try and do the exact same thing that get tile value does, nothing different, right? We're just going to do exactly the same thing, get the tile chunk. But the difference now is when that tile chunk, we want to be able to say if the tile chunk isn't there, we want to be able to create the tile chunk, right? We want to be able to say if the tile chunk comes back and actually is there, well, that's fine. We'll just go ahead and set it. But if it's not there, then we'll be very sad and upset and lonely in our life, and that would be bad. So what we want to do is we basically want to make a way that we can create tile chunks whenever we go to set a value somewhere and there is no tile chunk to store what should be there, right? So we go ahead and here we say if we do not get a tile chunk back, then we are going to go ahead and set that. So get tile chunk, if you remember, gets the, well, you know what we could do? This might be a little premature now that I think about it. Let's just go ahead and assert tile chunk for now and put it to do there. Because what I'd rather do now that I think about it is we're at the end of the stream. I'd rather spend more time talking about that tomorrow. Even though it's not really what we probably do. Eventually, I don't want to quite do that yet. So we're going to assert the tile chunk, and we're going to put to do on-demand tile chunk creation. But really, we're just going to take the tile chunk here, and then we're going to do that set. We're going to do like a set tile value. So we're going to do the exact thing here. We're going to basically mirror the get tile value in almost exactly the way that it works. But instead we're going to call set tile value, and then back up at the top where we've got our get tile value call, which retrieves the tile value, we're just going to do the exact same thing where we do the inverse operation. Instead of retrieving the value, we change the value. So here, yeah, so here we go. And this also would be a set tile value unchecked. A little worried about maybe there's too many levels here. I wonder if maybe we should just only have one of those, but what are you going to do? Well, we can always eliminate functions in the future. So there's our tile value. There we go. And so all we do is just reverse the sense of this setting. And there we go. Like that. And compile. So we need to pass the actual value here. This does not return anything. Make that. Take the value. There we go. And we don't need to return anything from you. We are passing the world arena by pointer now. And there we go. So now what will happen, of course, when we do this is we will crash immediately, or at least that's what I think we'll do, because we don't actually have those chunks at all. So we immediately stop right here and say, oh, there are no tile chunks. So all I'm going to do is I'm just going to pre-allocate a ton of those tile chunks. And then tomorrow we'll take a look at doing something a little bit smarter. So what I'm going to do here is I'm going to say, okay, we have our tile map. Let's go grab that. We have our tile map. I'm going to go ahead and say that our tile chunk X and our tile chunk Y are very large. You know, we've got tons of them, let's say. Excuse me. And I guess at this point too, it's unclear why we actually even have to make this be a dynamic allocation, but I guess we did, so we'll have to sort of just live with that. But what we can do here, since these are 256 by 256, there doesn't have to be that many of them. We could even just do that many. All I'm going to do here is just spin through here and allocate everything. I'm going to go into the Q&A a little bit because I just want to kind of finish up. We're almost there, and we're going to undo some of this tomorrow anyway, so it's no big deal. All right, so let's just do a quick loop through here. Nothing particularly fancy. I'm just going to loop through all the ones that we have, like this. There we go. And I'm just going to go ahead and store into our tile map, basically wherever the tile chunks are. I'm going to do the standard thing that we had to access the tile chunks. I'm going to do tile chunks y. I'm sorry, tile chunk count x times the y plus the x, and I'm going to go ahead and do a push struct there to push one of the tile chunks, so that we basically have a tile chunk in all of the locations that we wanted to. I don't know why I'm going by the wrong stride there. Always go by y first and then x. So we'll go ahead and push those on there. We also need at this point our tile chunks array. Actually, that's not what that is. It's supposed to be the actual tiles that we want to do here. So there we go. We want to go ahead and so you know what? I might just stop here. I might stop here just because I also got to talk about push array. Do I want to go about 5 or 10 minutes longer? Let's keep going. Sometimes we just got to keep going. All right, so I also want to do I want to do another one of these guys here, basically so that I can push things onto my arena. I want to do the ability here to push an array of things. You know what? This isn't push struct really. This is just push size, which is all it is. So all I have to do here, if I want to do an array of things, let's say I want to push an array of things, I just have to introduce a count parameter, right? And then multiply the size that I was allocating by that count. And then you could do the same thing for a push array. All I wanted to do here is I wanted to basically allocate this tile array. So I wanted to allocate UN32s, and I have to allocate however many there are in each one of these things, which is chunk dim, right? So I need chunk dim times chunk dim squared. It's because it's a what I think we said it was a 256 by 256 array for each of the chunks. So I need to basically go in there and create that array. And similarly, inside the tile map itself, I also have to go into those tile chunks, and I need to push an array there of tile chunks. And the number of tile chunks that I have, right, is going to basically be, and I need to pass that world arena there, game state world arena. Probably pull that into a variable. There we go. So I'm going to basically take that tile chunk array that used to be a static thing. I'm going to allocate that as well, and I'm just going to say, well, we know how many we have. We have the tile chunk count x times the tile chunk count y. That's how many there are total, and so that's all we need for that. And so that, I think, should allocate all of the tile map stuff for us. I kind of slammed that in there really quickly, and I apologize for that, but we kind of running out of time at the stream, so we'll have to go into a little more detail there eventually, probably tomorrow, or in the Q&A. You never know. Depends how the Q&A is. What are we complaining about here? What are we complaining about? Why are we complaining? Why are we being a grumpy little monkey? I don't even know why these are int 32s, to be honest with you. No operator found. Tile chunks. So tile chunks, this is the wrong thing. It's actually .tiles. There we go. So I don't know if this will work at all. Probably not. Yeah, didn't think so. What are we complaining about here? The size of this thing. How big is the size of this thing? Let's take a look. Okay. Useful size less than equal. What is arena size? Size is so we actually did use all of that. I allocated a few too many of those. It looks like that's a good reason to make those a little bit smaller. We'll have to think a little bit more about that in the future. A lot of things to think about here. Okay. So of course this should actually always be finding a tile chunk. I feel like so I'm not sure why that didn't find a tile chunk. I got to make sure that I did everything right here. Let's take a look. So the tile chunks, Again, sorry for just throwing this in there. Sometimes I get carried away. I promise I will talk a lot more in depth about this very quickly. But sometimes I get on a little bit of a tear, and I kind of had to go. I kind of had to go for it. And so, yeah, what can you do? So when I make the tile chunks here, I'm pushing this array. Let's go ahead and stop in here. Let's Win32 handmade, no handmade CP. There we go. All right. So we come in here. We go ahead. We initialize our arena, and our arena has nothing in it. Again, all our arena is basically all I'm doing here is I'm just saying, all right, I want a struct that basically tracks where I am in my memory storage, and every time that I want to allocate something, I'm just going to put it wherever I was and move this thing down one. That's all I'm doing, right? It's really, really trivial for now. That's the only thing it's doing. So memory allocation is just plus. That's our entire memory allocation scheme, is we just stick something wherever our current top is, and we just move it down by however much we pushed, right? So that's all I'm doing here. So I create one of those, right? Here's my my game state. I create one of these world arenas. I say that it's got all the permanent store in it, minus the part that we use for our game state itself. I give it the base pointer, and then there's nothing used in it. I then go ahead and push a world struct on there. Oh, and you know what I actually forgot to do? I forgot to clear these guys as well. So I wanna go ahead and do a big old to do here. To do Casey important. Let's leave that. Clear to 0 option. We need to do that as well. All right. So anyway, sorry, I forgot to talk about that a little bit. Anyway, we go in here, we create that, we push a struct on. So now we've basically in our memory stack we've pushed the world right onto the top of the stack. In fact, I'll draw it explicitly. We come in here. The game state is here. Right, game state is here. Our arena is pointing here. We push the world onto there, right? So the world's on there now, and now we've got a world, right? But our world isn't cleared to 0, which I said I want it to be. Oh, you know what? It is though, because our whole memory is cleared to 0. I remembered we spec'd that. So no, we don't actually need to do that. That's okay. I take it all back. I take it back, people. We do clear it all to 0, so that's fine. All right, so we come in here, we get down here, we get our world should be cleared to 0, it is. We then go ahead and push our tile map on there, we get our tile map has nothing initialized, and that's fine, so we have to go ahead and initialize it. We set the chunk shift, we set the mask, we set the dimension, and then we go ahead and create our tile chunks. Oh, that's fantastic. Well, that's our problem right there. We haven't initialized those yet. Where did that go, people? Well done, Casey. Move that up there. All right. So we go ahead and set that, then we allocate. So let's go ahead here. Let's do. There we go. We push that array on there. So now we've got our tile map and our tile chunks are just sitting there, but there's actually nothing, I guess, in them yet. And that's fine. So we go ahead through here and we spin through each of them and we allocate tiles for them. So now they all have tiles. Right, we go through each one of our tile chunks and we allocate tile chunks. So it's not sparse yet. This is actually just a dense tile map, a giant dense tile map. And so then we go ahead and initialize the rest of the tile map parameters, and then we start setting tile map parameters per screen here. So we go into that set tile value, and then let's see. Well, I guess now it works because I actually allocated a thing right. So that's fine. We go through and we set them all. And then our game is running, and we're in a giant empty world. So, presumably, if we wanted to, we could create a very large world here just to end the day off. Not too much overtime, 10 minutes overtime. When we set the tile value here, we could do something like, if tile x equals tile y, right? Tile x equals tile y, and tile y mod 2 or something. We'll just do that. Then if that's true, then there's something there, otherwise there's not. Just so we can see that we set things. Oh, and of course I happen to start out right in one, of course, Isn't that always the way? Let's go ahead and change our starting parameter here. I don't remember where the dude actually starts out. I think he starts out on 3.3, so let's just make him start out at 1.3. All right. So there we go. Now we've got some. Now we've got, like, I don't really want to call this a world. It's not a particularly compelling world. That's true. But at least some things are set, and that's always good, I suppose, for lack of a better thing. All right. So there we go with that. And I feel like we should have been setting more screens. This is supposed to be tiles per height here, so that's a bug as well. I feel like we should have set more screens worth of that. There we go. So there's our other things. So we now kind of have a relatively big world that we can play in, which is always fun. But I kind of spammed a lot of stuff out there, so I apologize for that. That's one of those habits that I probably should break on the stream. You don't want to just go, code wild. I tried to explain everything while I was doing it, but I realized I probably introduced too many concepts there. So anyway, we're in pretty good shape here. We've got all that stuff working. Let me just briefly re-say what it is that I did. So previously we were creating everything on the stack, just in here in game update and render, and what I wanted to do is I wanted to move it all to the memory, the actual permanent memory storage, right? So I did that. The way I did that is I made a really simple thing that's basically, it's the memory allocator. It's just a very simple one. And the way the memory allocator works is it starts out with all the memory and it points to the bottom of it. And then as soon as you allocate something, it just uses whatever the next chunk of memory is and moves down to the bottom. You can't even ever free anything in this scheme, right? It just keeps using memory. So I basically then just converted everything that we were declaring on the stack. I converted it to using the push array or push struct, which basically just pushes a size onto that memory chunk. I went in and I pre-allocated everything because I didn't want to get too far down the rabbit hole. But basically what we're going to do tomorrow is we'll actually make some real screens here. So we'll actually make some logic that draws some screens with doors and stuff so that we can actually start testing that a little bit. But what I want to do and what I wanted to get to, so hopefully we'll get to it tomorrow, is this set tile value that will basically go ahead and allocate as necessary the tile chunks. Now one thing that's also true is we're using 256 by 256 tile chunks at the moment, but I do wonder, and also I suppose we should set this chunk dim value. We can set this off of the chunk shift as well, right? We could just do that because that's going to be 256, right? Does that make sense? So anyway, if we run this, we've got our thing. I wonder too if we could quickly test how our chunked system is working exactly by going ahead and going in here and saying, okay, what if we were to make really small chunks, right? And I don't know what would happen if we did really small chunks. So we do really small chunks, and then we beef this number up a bit, right? I don't know if that's a good idea or not. Yeah, I feel like the problem is I have to make it big enough now after I make that so that these will be, there's so few of them now that I have to make sure that we get enough of them. I didn't actually bother to compute how many it would be. Can we do this many? I don't know how many we could do. Yeah, and of course we can't do too many for the arena size. Should probably think about how big that arena size has to be. So now our chunks are actually much smaller, right? Our chunks are now only 4 by 4, I believe I say. Oh, no, we set the shift. So they're 16 by 16 chunks, right? And so now we're traveling across many of these chunks, and I'm just wanted to make sure that our system was working fine. So basically we can change sort of that page granularity to be whatever we want it to be, and that's kind of nice. So that's a good thing. And here we are running all around our world. Very exciting. All right. So, yeah, sorry to spam all that at you, but I really didn't do very much. All I did was just move things over to that permanent memory store. We haven't actually talked about how we're storing any of these things yet. We literally are just doing exactly all the same things that we were doing before, just now we're doing them in a way that's actually proper and permanently stored, so it persists from frame to frame, and if we were to change it on any given frame, that would work. So yeah, so tomorrow we will do our sparse storage, which will be fine, and I think that we didn't actually put, did we actually put a to do in there for that. On-demand child chunk creations, that's good. That'll be our primary to-dos for tomorrow, but that's about it. All right, so we can still get in 15 minutes of Q&A. That's not too bad here on day 34. So I will go ahead and start the Q&A. Sorry for taking up a little bit of that time, and I hope that made some sense what I was doing there at the end. I just wanted to kind of get us back to a running state. I like ending the day on a running state, so sometimes I go a little bit too far, and I have to quickly do some stuff, so I apologize for that. Anyway, if you could, please keep the questions to stuff we did on the stream today or on a previous day. That would be very helpful to stay on topic. And please make sure you put Q: in front of your questions so that I see them. Let's see. What have we got for questions? Questions. Gotta wait for the questions. Of course, you guys don't hear this till after I have said it quite some time ago. Garlando Bloom, hello. Hello to you as well. Can you explain the motivation behind controlling the page granularity? Yes. So let's talk about this a little bit, because this will be a good setup for what we need to do tomorrow. Okay. So basically what we want to do, if you think about it, is we have to store a world that has potentially very large dimensions, is what I would like to be able to do. Because I don't know how big we want to make our game exactly, but it might be pretty big. So basically we have a possible size of 4 billion by 4 billion tiles. Okay? That is far too many tiles that we could possibly ever hope to store, obviously. 4 billion times 4 billion is more than any machine's memory has. I mean, maybe, the NSA or somebody has something like that. But 4 billion times 4 billion is way too big of a memory for any computer that anyone's going to run the game on, so we certainly can't just allocate an array of 4 billion by 4 billion tiles, because no matter how big the tiles were, even if the tiles were 1 bit per tile, it still would be too big. So what we need to do instead is we need to say, all right, obviously we can't make a world quite that big unless it was entirely procedural and couldn't be modified, so that when you walk to a world location, you really just got a generated world right there, and you couldn't modify it. You wouldn't ever modify it or save it or anything out, because eventually that would run out of space. So if that's the case, then what we're saying is there's some subset here, right, where the actual world exists. So there's some subset where there actually are tiles, and I don't know, you can imagine like a little thing, that kind of all these like are tiles that are filled in or whatever, right? And maybe they're kind of eccentric, so they don't densely cluster always. Like there are dense clusters of them, like maybe there's a lot of them right here, but there's like winding bits that kind of wind around and whatever. And so now what we have to do is figure out how to store this. So what we want to do is we want to have a way of storing it such that we can kind of isolate the regions, right, where there actually is something going on, and kind of box that out and store it, but then not ever store anything out in all these other regions, right? And so we haven't actually talked about how we're going to do that yet. We have to start doing that, and that'll be maybe what we start talking about tomorrow after we finish our on-demand allocation stuff. That's what maybe we'll talk about. But basically, what we already have to think about, and what we already wrote, is the concept that we need some way of creating small tile sets. And in this case, like I think I left it set at 16 by 16. 16 by 16 tile sets that exist somewhere in the world that we can basically use as our tile storage, and wherever there's tiles, we'll store those 16 by 16s around where that is, and when there aren't, we won't. Now the question that the person was asking is, how do you come up with this? Why are we storing them this way? How come we're storing them in chunks? The reason for that is because basically what we're going to have, no matter what, is we're going to have some kind of an indexing scheme that allows us to get at the tiles that are actually stored, right? We're going to have a tile index. You know, we've got a tile index that's over here, and we want to ask the question, is there anything stored there? Now, if we were to actually store the tiles themselves in that table, the table would be too big in order to be, the table itself, if we wanted to make it efficient, whatever the indexing scheme is we use for those tiles is going to incur way too much overhead because there are so many tiles that are filled. We don't want to store sort of this infrastructure for querying them directly because the infrastructure itself that we will build for the sparse stuff would be too heavyweight in and of itself. So what we'd rather do is have an infrastructure that just deals with some aggregate amount of tiles, such as 16 by 16, 64 by 64, let's say, something like that we have to pick, so that the infrastructure can deal with far less of these, right? Because let's say we do 64 by, let's say what, okay, to put this in a little more explicit terms, let's say that the infrastructure has a certain cost to storing how it's indexing these sparse tiles, right? If I have to do 64 times 64, let's say, right? That's 4,096 tiles in a page, right? That means that essentially I can reduce my infrastructure cost by 4,096 times just by using pages of that size, right? Because whatever it costs to do the indexing, if I was doing them on individual tiles, it cost me 4,096 more infrastructure costs, whatever that infrastructure is, than if I was doing it on these pages. So basically, the page granularity is about finding that trade-off where the infrastructure, where you're still fine enough that you're not massively overstating where the tiles are, right? Like we could make it be 4,096 by 4,096, but then it's like storing tons of stuff that doesn't need to store. So we want something small enough that can capture the sort of shape of the actual stuff we're trying to store, but we also want it to eliminate to cut that total number of things that are being tracked by the infrastructure down enough that the infrastructure itself doesn't become a problem. And, you know, it's not out of the question that sometimes you even do these things hierarchically. You can imagine doing like 16 by 16s, but then those 16 by 16s are in something that itself has 16 by 16. There's different ways of doing it. But since we haven't talked about how we're actually going to do this sparse storage yet, we don't actually know what that's going to look like. We can't make a good trade-off yet, but I know it's probably going to be something like this. So I just started us off by having little tile sections because we're going to want something along those lines. Chronal Dragon, I'm a little confused about the purpose of the memory arena. Would it be accurate to say it's for more temporary objects than we're storing in the game state directly? No. So basically, here's what's going on. So we need to store our game state, right? And we need to store the whole game state, right? We need it to be persistent. We may even need to save it to disk in the case where the person stops playing for a while and wants to come back to it. We're kind of doing a roguelike style game, so we may never save it to disk in the sense that you can save and load your game, but if the user needs to quit for a second and come back to it tomorrow night or whatever when they're playing, we want to be able to have them quit and they can just load back up where they were or something, right? So it may even need to persist to disk. So basically this whole thing, right, this game state, we need to store all of it. And what does the game state entail? Well, it's going to entail the world map that we generated, right? It's going to entail all the entities that exist in the world. It's going to have any attributes that they have, right? Or things. And it's going to have score or gold or whatever, whatever the things are that the player has, all that stuff. This is all part of our game state. So we need to store it all somewhere. And so what we need to do is we need to have a place to store it. Now, what you'll remember is our game state structure, right, actually does contain all these things. Our game state structure contains the world, it's pointed to the world, it's got the tile map position of the player, the world has the tile map in it, blah, 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 right? So all the memory arena is it's something that allows us to conveniently put more things onto the permanent storage. Now, you didn't see it cost anything because the first thing we allocate in the permanent storage doesn't require any work. It's just pointer to the permanent storage. Whatever the base of the permanent storage is, we stuck our game state there. That's free to do. But can you imagine what would happen if all of these things, I had to do the arithmetic for figuring out where they were in the permanent storage? That would be a huge pain, right? This would have to be, okay, take this and add however big it was and do it, and then this thing would have to figure out, okay, where was the world? Okay, put it after the world by however big the world was, and then this would have to go and do blah, 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 right? So all the memory arena is, the only thing that it's doing for us right now is basically saying, automatically lay out where all of our stuff goes in memory so we don't have to do it manually. So all it's doing is it's storing stuff in the permanent storage just like the game state, but it's laying things out for us so we don't have to do it ourselves. It's an automation for that, right? Let's see. Why not have smooth scrolling and have the world generation add edges where scrolling stops, acting as rooms or local tile maps? Yeah, so that is essentially what we will be doing. It's just I don't like smooth scrolling. So we won't really have any rooms that are bigger than can fit on the screen. Does that make sense? So that is what we'll be doing. We'll have the world generation generate rooms, that, kind of have a certain layout to them, right? Like this sort of thing. And then the camera will just always be looking at one of them, and when you walk off of one of them, the camera will switch to be looking at a different one. That's what we're going to do, right? Yeah. I already have the OI compiler flag set. Oh, do we already have the OI compiler flag set? Yeah, we do. So I wonder why, I guess, you know what? It's probably FP fast. It's FP fast probably that we didn't. You know what? And we can probably just set that in our compiler flags in general as well, I suspect. That would totally be fine, because that's not really a debugging issue for us, and we just don't want to call the C runtime library pretty much. So let's take a look at what that does. Assuming that we have FP fast set, I feel like then when we are in the tile, so let's see, round real 32 to int 32, or is it uint 32, I think, that we actually used. But either or, let's go into the disassembly here and just see if it did the right thing. Yeah, so that's great. And that's what I like. It's not, oh wait, no, never mind. I got too excited. It's still calling roundf. Lame. Oh well, what are you going to do? So anyway, yeah, I was hoping that basically minus FP fast and minus OI together would do it, but maybe you actually, I guess, do you have to specify minus O2 to get it to do? Let's see. Where is the place that does that? Where is my tile? I want my tile routine. Get tile value. There we go. So let's go ahead and see. It inlined that, didn't it? Yeah, it's inlining. It's inlining everything, which is good. I like inlining, but I don't actually know. Goes to assembly. I don't actually know what it decided to do for rounding. Let's take a look here. Did it ever call roundf? Get tile chunk and get tile value. I'm not seeing a call to it. So that's, although it doesn't actually, never mind. It doesn't actually need to do that. For recanonicalized coordinates, that's going to be in the other one. We only ever call that back here. So if we wanted to see whether it ever calls roundf, we've got to look in here, right there, right? Basically, right? We got to look at what it does when it recanonicalizes. So let's take a look and see. Recanonicalized position is going to go ahead and do null ps, shuff ps. Why is it, what's it shuffling out? I guess I shouldn't be looking at this now. This is not really what we should be doing. No, so it still calls roundf. So that's lame. I wish it wouldn't do that, is I guess what I would say. But I guess we'll have to basically, like I said, we'll have to write that ourselves. What are you going to do? If the compiler wants to call roundf, it's going to call roundf. Does using the memory arena still allow you to hot load your code? Yes. In fact, that's the reason that we have things set up the way that we do. So if you notice if we want to do stuff like our loops live code editing, I can totally do that. So we come here, and there we go. You can see it's reloading properly just as it was before. No big deal. The reason for that is because that memory arena, again, don't be fooled by names of things. Just because I called it a memory arena, I called it that because that's sort of what I think of it as being. But look at what it's doing, right? You can answer this question for yourself. The memory permanent storage, where did that come from, right? Where did that come from? You remember because we allocated it, right? We allocated it with virtual alloc. So what we did is we did our virtual alloc here. The permanent storage came out of it. The transient storage came out of it, right? So we have that one memory block. Now that memory block, remember, is getting persisted by everything that we do, right? So everything that we do with the loop live code editing and all that stuff is getting persisted, all this whole block. Now, permanent storage is the memory that we have here. The arena only uses that memory in permanent storage. It's only just, all it's doing is giving you back things that are inside the permanent storage. It never calls an allocation function or anything. So basically what happens there is all of the stuff that goes through the arena is always going to be persistable because it's always going into that one memory block, right? And so that's an easy way to think of it. It's like basically everything's going in there. So there's no issue with persistence with that. Will we be covering trig approximations? MSCC doesn't seem to have trig. Yes, we'll have to implement our own sine and cosine, because at least last time I remember looking at it, I don't think SSE has anything like that. SSE doesn't have sines and cosines. You have to do it with like series expansions and stuff. So we'll be doing those. Will there be enough memory to store the entire sparse tile map, or will we be paging it in and out in chunks? I feel like we'll use enough memory for that. I feel like, I don't know. I mean, we'll have to see. These are the kind of questions I can't answer off the bat because we haven't even really made the game yet. And once we make the game, we'll have a feel for how big we want the world to be. And if it turns out that answer is that sometimes you want to set it to be huge, maybe we page things in and out. It's not impossible. Paging in and out would certainly work fine. So. Let's see. Why not just allocate a large, giant, one-dimensional array instead of the current tile map tiles two-dimensional array and refer to it by y times width plus x format? So, well, first of all, everything in memory obviously is one-dimensional. But there is a question, there is a sort of a question in there that does bear analysis, which is how you choose to break up the world stride-wise, right? So, basically, we could do one of two things for storing chunks. We could store long, thin chunks like this, or we could store rectangular chunks like this, right? And these would be the same size, right? Let's say this was, a 4x4, right? So we can store something that's like this sort of thing, where we basically have 4 things per chunk, right? Or we can store this sort of thing where we've got a 4x4, right? So we can have a 16 by 1 or a 4x4, right? We could make those decisions. And there's a difference between these two. And the difference is when we actually go to do sparseness, remember, we've got this whole world and we've got some stuff in it that we want to represent. And now what we have to do is we have to accept some additional storage that we didn't actually want when we go to fit these things to this thing, right? So when we actually go to do this, we're going to have that problem, right? Now, what we don't want to do is pick a shape for the sparseness that will have negative connotations. Like when we want to store, a thin thing that people are walking up and down, you don't want to be storing all of this extra stuff out here that would happen if we were storing with this long thing. So because we know we're having rectangular rooms and that sort of stuff, this is going to be a much better fit. A rectangular or a square piece is going to be a much better fit to fit the data that we actually want, if that makes sense. So that's why we're going with chunks that are that size. Now, there is a question, which is that if we have a canonical screen size, and that does end up being 16 by 9, don't we want to store them as 17 by 9 chunks? And the answer is yes, we kind of do. And so what we may decide to do is actually use 17 by 9 chunks eventually and eat the extra cost of doing the lookups, because the lookups become a lot more expensive when these aren't power of 2, right? So there's that. You are using a lot of pointers here. How are you managing the memory regarding leaks and UMR, etc.? Well, I'm not really sure I understand the question. So I guess I'll kind of give a general answer. The way we're doing things, we just use a memory block. So we don't have any memory leaks. Like that memory block gets freed at the end. There's no way we can leak the memory. So there isn't. I mean, this is something that I guess that I don't know. You kind of just have to watch and see how I do it, I guess, as we go forwards. But people often ask me this question. They're like, "How do you manage memory, or how do you deal with garbage, not having garbage collection, all that sort of stuff?" There's no memory to manage in a game. Like games typically just they create their stuff and then they run. There isn't any memory to manage. It's usually just people sort of misunderstanding the basic way that you should probably program things, I feel like, when you have lots of memory getting allocated and stuff like this, that has to get managed and freed in that way. And so if you'll notice, I've never allocated any memory that has to get freed. I've never done anything that requires tracking of pointers or anything like that. And that's intentional. This whole game will be structured in a very clean way such that that sort of stuff never happens. So there won't ever be any leaks because there won't ever be any allocations, if that makes sense. When we create the worlds will get created as one in this block, and when you close that down and go to a new one, it'll just jettison the entire block as a whole and start a new block, right? So you never have to worry about freeing forests of things, which is where you need garbage collection and stuff to help you if you are getting confused or whatever. You just don't ever do those things. And so, yeah, this is why a lot of times I guess people find it weird, but I don't think about memory management. Memory management isn't an issue. How much memory I'm using is always an issue. But that's because I always try to think about keeping things constrained. Like, I always try to think about, let's keep everything inside like 64 megs or something like that. And that's always something that you have to work on and think about, because using how much memory you actually need is a problem. But freeing it and managing ownership and that sort of stuff is just, you should never even think about that or even have to think about that. If you're thinking about that, you probably did something wrong in your architecture and you should rethink it, if that makes sense. And so you'll just have to kind of trust me that that's true, and you can see as I go that I always have a good solution for that at all times, and that I'm never in this situation where I'm like, oh, and then we have to free the thing, and oh, but that points to other things and those have to get freed. You never, like, don't do that. Just never ever write that code. Because it's basically like it's not necessary, and when you write it, either you have to use a language that has garbage collection because you can't manage it yourself because it's too complicated or something, and that incurs all these costs for the garbage collection and all these other things that don't have to happen. You're just wasting the user's time running all that stuff like the garbage collector. Or if you're writing a language without garbage collection, you're making a ton of more work for yourself, having to remember what's getting freed and what's not, or using all these smart pointers to do all these checks. And those checks incur extra cost, and you're just incurring all this extra cost, all this extra work that the CPU does or that you're doing mentally, all that stuff that never needed to happen. So just don't write that code. Like, never write that code. Write it this way, and then you never have to worry about it. And I think that's just generally a very good rule of thumb. So there you go. Will memory arena be aligning the assigned memory depending on the size of the first element of the struct? Well, eventually when we care about alignment, actually we will probably be passing an alignment to the arena. Because when we actually care about alignment, we will be caring about the alignment on probably things like 16-byte boundaries or something like that. Don't forget to disable O2 again. That's a good idea. Thank you. Thank you, MXSY. Let's see. x86 ISA has signed coast. So it doesn't, unfortunately. So basically, I mean, it does, but we're in x64, and you have to use the FPU to do sign coast, so you really don't want to go that route. In x64, you really don't want to call sign coast. You want to do the other way, if that makes sense. Like, because x86 had the x87 FPU, which had syncos, but you never want to use that anymore because it's way slower than the SSE registers and the SSE path, SSE2 path. So we're always going to be on the SSE2 path, if that makes sense. All right. Let's see. Why don't you use lookup tables for sine and cosine? You'll see when we get there, it's very easy to do them in SSE2. Well, it's not easy, but basically you don't want to introduce memory to solve something okay, well, let me just quickly say. The reason you don't use lookup tables anymore for most math operations is because what's the most expensive operation you could do on a computer right now? It's memory access. Memory access is like oftentimes 100 times slower. Oftentimes 100 times slower than just doing an operation. So if you can do 100 operations to do your sign, it's probably faster than polluting the cache with a sine cosine table that will now slow down memory access overall, because that's another thing that causes cache to be evicted and can miss and so on. So lookup tables, unless the thing is crazy expensive, I mean, it better be so expensive to compute. It better be thousands of instructions or something to compute. Do not do lookup tables for operations that aren't very, very expensive. And sine and cosine aren't that expensive. So you probably don't want to use lookup tables anymore. I'm not a hardcore optimization guy, so I don't want to say definitively never use a lookup table for sine and cosine. That's not my place to say. I don't have that kind of authority on those sorts of matters, certainly. But what I would say is it's highly unlikely that we will do that, because it's usually the case that you can come up with something that's not too many SSE instructions to do it, and then you're not using those precious memory accesses which you really want to use for other things. Let's see. D. Dangster, regarding what you said about memory management, how can you say you don't need to free up memory when you start spawning infinite numbers of enemies? Well, you'll just have to see what we do when we start throwing enemies. I don't want to give away the surprise. Why would you keep coming back to the Twitch stream? I guess I can give you a little hint, which is that you can't have an infinite number of enemies. There isn't enough memory to store an infinite number of enemies. So I'm pretty sure you only have a limited number of enemies. And if you only have a limited number of enemies, well, you should have a pretty easy way of spawning new ones when old ones go away. Let's see. Enemy mouse. Is memory access slower than mod? Yes, I mean, memory access is slower than everything. There's nothing slower than a memory access that I'm aware of. Like, I don't think there's an instruction. I don't know. Someone correct me who's an assembly language guy if I'm wrong, but I don't think there is I don't think there is any instruction you can execute that's as slow as the memory access. Memory access is the slowest operation. The only time you can get operations, the only time you can issue instructions that are slower than things that gather data is if that data is in the cache. The cache can be faster sometimes than instructions, but memory, no. If you're actually going to main memory, I don't think there's a single instruction that you can execute, no matter what random instruction it was. But especially not SSE2. SSE instructions tend to be 2 clocks. And I think memory accesses can often be like 200 clocks. So I literally think this 100x is not off base. Like, I think you're talking about like 2 orders of magnitude, 2 decimal orders of magnitude. between the average SSE instruction and go into memory. Why are tiles used? To reduce calculation or some other reason? What is the real benefit of tile mapping? What will happen if we did not use it in Handmade Hero? Well, basically I wanted tile maps because I felt like we needed some basis for our world at the lowest level. And there's really only two choices sort of that we can do. One is like polygonal, right? We could sort of define our regions, our walls as polygons, or we can define them as tile maps. And I felt like tile maps have kind of a nicer understanding for the player. Like players can understand tiles a little easier. They can do those kind of puzzles where you have something that you push around the tile map easily, and you can actually make puzzles that the players understand instead of just like random. I just feel like polygonal things, they turn into these random physics bouncing around things, and there's no concreteness to them. And so we won't ever render things as tile maps. We'll always be rendering things more robustly and colliding with things in kind of a more interesting way than tile maps. But the basic part of the world, I just kind of felt like tile maps was a good way to go. And I felt like it kind of tied us back to sort of the old school games as well in a way that I thought was nice. All right, I think we are basically done with there are some few instructions. Well, let's see. There's some few instructions that can take the order of 800 cycles on Haswell. Well, okay, but x87, because the x87 is like really old school, right? 600 cycles. Like, what FPU instructions are we talking about? Because I don't think if you're talking about the x87 FPU, that's legacy part, and you don't ever even call that anymore. So I wouldn't actually call that be true. Well, anyway, we can talk about that on a different stream. Anyway, I think we are basically we're already 15 minutes over time. So we've done a full Q&A, even though I went over time. So I'm going to call that the end of the stream for the day. Thank you very much for joining me, everyone. It's been a pleasure programming with you, as always. I'm going to go ahead and close this down here. There we go. If you would like to follow along at home, you can pre-order the game at handmadehero.org, and you will get your own copy of the source code, which you can download every night. I upload it after I finish programming every day, so you can go ahead and follow along at home. It's kind of cool way to be able to do that, and that will also come with the art assets that we use during development as well. And of course it comes with a copy of the game at the end, which should be pretty awesome as well. So definitely check that out if you're interested. And the other thing is we have a Patreon. If you want to support the video series, you can subscribe to our Patreon as well. Now, if you're trying to learn from the series, that news and forums button I just clicked on is a great place to go to. It has all sorts of stuff for you. It has a code discussion forum you can ask questions on. It's got coding resources, so if you want to look at people have done ports to Mac and Linux and so on, so if you're looking to run it on other platforms, that's a great resource for you. And an episode guide you can use to catch up. It's also got the schedule for the week that I post every Monday. So if you are trying to follow the series closely, that is a great place to go. So thank you, everyone, for joining me. Tomorrow we will be right back here at 10 a.m., not too long from now, just 12 short hours from now. I will be back, and we will do a little bit of our sparse allocation stuff just to get that stuff working, and then I don't know what we'll do after that, because we probably want to sort of close out the week so that we can start next week on some fresh stuff. But anyway, so please join me tomorrow at 10 a.m. Pacific Standard Time. It would be great to see you here tomorrow on Twitch for more Handmade Hero. Thanks, everyone. Have a good one.